The Assalamualaikum students. Hope you will be fine. Yes, I was talking about the work energy and power in my last lesson, and today in this topic we are going to talk about the next aspect of work energy and power, that is power. So when we define power, power is actually the rate of doing work, or rate of energy conversion. So how faster the energy is converted from one body to other, or during one mechanism to the other mechanism, that is called power. So its formula, what we use for the calculation, that is power is equals to work done divided by time, or simply you can also say that it is equals to energy divided by time. So these two equations are used for the calculation of the power. So from these equations, if you see that what is the unit for the power, power's unit, actually SI unit of the power is watt. What is SI unit of the power? Power SI unit is watt, and it is scalar quantity. But if I see the basic or defining formula, it is joules per second. When it is joules per second, it means that watt can be defined as joules per second. So sometimes it is asked that define joule or the define watt. So it is, you can write joule per second. Then we will talk about that if here is the situation of 1 watt power, then 1 watt power is defined as the rate of work done or energy conversion of 1 joule per second. So power tells us actually how faster you are doing something. But generally, we do some work, we calculate the work, but how faster the work is being done, that is basically delivered, or that is represented by power. So there is another formula for the power, which consists of the fast motion, or you can say the extent of moving body. So that is power is equals to force into velocity. That is force into velocity. That formula has very small derivation. You can consider it that if I say that power is equals to work done divided by time, and then work done is equals to force into distance divided by time, and then force will be taken out separate, and distance divided by time is taken out separate, and that gives you the distance divided by time is your velocity. So that formula helps us out to find out power when an object is moving with constant velocity. Remember one thing, this is really important, that this formula is applicable when the object is moving with constant velocity, right? Constant velocity means it is not changing the direction. Force is applied. I mean, the object is under the constant force, and that object is having constant velocity. Then we use that formula. Okay. Then we have the next aspect of our topic, that is efficiency. Actually, this word is very common in our daily life. When we say that what is efficiency, then efficiency means how much useful output is being provided by any system, or what is useful output provided by any person or the system or any machine. So efficiency is actually defined as, you have to know the definition of this efficiency. Efficiency of the system is given by the ratio of useful output, very important information, that is the ratio of useful output to the total input. So here I have mentioned two things. Either you can take ratio of energies, or you can take ratio of powers. Either you are using energy as an input, then output would also be taken as energy. But if you are taking power as the input, then an output will be taken as power. So that is why I have mentioned that either energy or power. So when we just have a main concept of this efficiency here with the help of a diagram, this is the total energy provided by the system as an input. That energy is divided into three different categories of the energy. One of them is that green one. That green one is basically that useful energy, right? Whatever the amount of that is, I'm going to formulate that. That's why I don't need numerical values. So that is your useful energy. And then these two energies are wasted energy in different formats, whatever the format is. But if it is not useful, because when you are just running a car, you are providing petrol to it, that is the input energy or chemical energy, and that car runs down the street, so that is its useful energy, or you can say its mechanical energy, and this can be sound and heat. So when I say that this energy is in the form of sound and heat, that is waste of energy. It is not my useful energy. So whatever the form of energy do we have in the form of heat and sound, we can consider it as a waste. So here, that all energy is taken as input. Total, whatever you are going to provide, it is total energy, total input energy, and then this is your useful output. I can call it useful output energy, useful output energy, and the third one, which is here, I can write with red. It is basically the wasted energy, or lost energy, or dissipated energy. So that is not used as an efficiency, or that is not used for the calculations of efficiency. Now let's talk about the principle of conservation of energy. So when we talk about principle of conservation of energy, principle of conservation of energy is also named as law of conservation of energy. Right? This is also named as law of conservation of energy. Okay. So when we talk about this law of conservation of energy, means that energy, whatever the input energy is, that is converted into total energy. Total energy can be of your use, it cannot be of your use, but overall the energy will be same. I mean, energy will be converted to the output without any loss. So there are two, three definitions for that, and those definitions are those statements. Sorry, not definitions. There are statements for the laws, that the total energy output of any machine must be equal to its energy input. That sometimes energy is lost in different forms, as I told you, but definitely whatever those forms are, they are forms of energy. So the machine is always, I mean, the output of the useful output of the machine energy is always less than the total input. This phenomena can be attributed that work done against friction forces, work done against different forces which are dissipating energy, which they are utilizing energy, that is wasted. So we can simply say that the total energy input is basically equal to useful energy plus wasted energy. So if you add both energies, either useful and wasted together, what will you get? You will get the useful output energy. That is why efficiency has this formula. You have to recall this formula, please. This formula is very important for calculation. That is, efficiency is useful output, or useful energy output, divided by total energy input times 100. So when we are using that one, I am emphasizing on this word, energy, right? So if you are using power, then you will use power in both the cases. If you are using energy, you will use energy in both the cases. So here are those snaky diagrams of the energy. This system, if you see that the total energy provided to the system, electrical energy, is 100 joules, but that is some sort of old variant bulb that uses, or that utilizes 25 joules of energy as heat, and 75 joules of energy is used as the output energy. So sorry, it is not old variant bulb. Old variant bulb is the other one, brighter one. This is your, this is called your energy saver, because it has saved your energy. So out of 100 joules, 75% is basically used as the light, or that is used for the useful. That is why it is 75% efficient. But what about this one? In this right one bulb, you are using, or you are providing 100 joules of energy, electrical energy, and that electrical energy is converted to just 10 joules of light. Rest all is heat, converted into heat energy. So that is just heat loss. Okay, so this is just 10% efficient. How much percentage does it have? It has just 10% efficiency. So in this way, when we talk about efficiency, we consider useful output as the calculation. So if you want to if you have power in the given data, sometimes powers are given. For example, bulb is using 100 watt as an input, and it is using 70 watt as an output. So powers are given. So in case of powers, you have to use the formula of useful output power divided by total input power times 100. That will give you the efficiency. Okay. Till this point, I believe that everything will be clear to all of you. Then we will talk about one important factor here. I have just figured out some of the example. If an electric motor has an efficiency of 35%, it has or it lifts 7.2 kg of load through a height of 5 meter in 3 seconds, right? Calculate the power of the motor. That is the question. So when you are going to solve this question, what you have efficiency. This is 35% efficiency. Then you have mass given to you. Okay, mass is given to you with the mass lifted by the motor, and then height is given to you, and time is given to you, and you are supposed to calculate the power. So what will I use, or what will I do? I will use that efficiency formula in terms of power. So useful output power divided by total input power. Just calculating in front of you, that is, if you are having useful output, you are actually you are delivering, um, it is what it is, the output power of the motor, input power of the actually, sorry, not output, input power of the motor is to be calculated. So you have to calculate input power. So if I apply this formula here, check this one out. Power, I have just rearranged this formula, that input power is equals to, from here input power is equals to, it would be shifted here, efficiency will be divided. So output power times 100 divided by efficiency. So by using this formula, you just came to know that output is in the form of mgh divided by time. That is basically output energy. I will convert output energy in terms of power. Okay, because when motor is lifting some load, it is doing some work on potential energy, or in the form of potential energy, and potential energy divided by time will give you the power in the form of potential energy. So it will be multiplied by 100, and efficiency is 35. So mass is 7.2 kg. 7.2 kg is the mass, and value of g is 9.8, and height is 5 meters. Okay, and in 3 seconds. So this all would be multiplied by 100 and divided by 35. So your answer will be this much. Okay, this is basically step-by-step calculation. I have calculated output energy and then output power 117.72, and then we have used that in that calculation. I mean, with the help of calculation, this is your output power. So input power was equals to, what was input power? I told you that input power will be equals to output power times 100 divided by 35. So I have no calculator at all. That's why when it would be calculated, 117.72 is this power times 100 divided by 35. So you will get your input power. Okay. So that is your input power. So in this way, we can calculate different forms of the power and efficiency, or we can use the data for energy calculation or efficiency calculation. There are several other examples, but because when we will practice the past paper questions, then I will solve those, or I will attempt all those questions for you. So this is first, this is related to power and efficiency lecture. So I believe that it would be very clear to you. And if not, then we will just have the cross questioning, and then inshallah the things will be clear to you.